Okay, for this question, it is a bit difficult because now we want to get the center of gravity for this big object minus this small object, because this small object is drilled away. So your real area is just this shaded portion. Okay, now how are we going to determine the CG of this shaded region only? Okay, first of all we need to understand the formula to determine the center of gravity for a solid object. Okay, what is the formula? What is the formula here? Okay, the resultant, the A resultant, X resultant equal to A1x1 plus A2x2 plus etc etc, depends on how many segments you have. Okay, this X represents the X coordinate. If I want to find the Y coordinate, I just simply change to AR YR equal to A1 Y1 plus A2 Y2 etc etc. Okay, so in this case we need to find the center of gravity for this blue shaded object. First of all, we need to determine where is the zero reference. Okay, usually in this case we choose the left side here as 0 0, so we start our reference here at 0 0. Let's draw with a straight line. Okay, this is the 0 0 here. Now this is the 0 0 location. Now this is start with 0. Okay, now then the horizontal line will be here as well. Okay, this is also 0. Okay, now this is 0 0 coordinate. In other words, every time we want to find the center of gravity, we must define where is the 0 0. So in this case, this point is the 0 0. Okay, now after that we need to get the resultant. Okay, what is the resultant? Resultant is this area minus this area, right? Then only we can get the shaded region. So we just plug it in the equation. Now what is the meaning of A resultant? Obviously A resultant means this big area minus this small area, then only we get the shaded area, right? So okay, so what is the big area here? Big area is pi r square. What is the r? R is 6 cm for the big circle, right? So pi r square. Oh, we need to minus off this area for the small circle here, which is pi times r square is 3 here, so pi r times 3 square. Okay, now times the X resultant. The X resultant is the one we need to find later on as the center of gravity, this X resultant. Now equals to, what about the A1? Okay, A1, let's say the big circle represents the A1. So A1 is what? Area 1 is pi times the r square. Okay, now what about X1? X1 represents the center of gravity for the big area. So where is the center of gravity for the big area? Definitely is at the center, right? The center, which is how many cm away from our reference 0? So here's our reference. Here's the CG for the big area. So the distance will be 6 cm. So X1 is 6 cm. Okay, now in this case, can we still use plus? Cannot. We must use minus, because in this case we want to minus this away. Okay, so now let's say the A2 represented by the small area here. So what is the area for this small circle? Must be pi times 3 square, right? Now this is the area of this small circle. Now the tricky part is X2. What is X2? X2, I've told you already, X represents the CG for this area. Similarly, X2 also represents the CG of this area. So in this case, the A2 is this small circle here. So where's the CG? Definitely for the small circle, the CG is at the center of the circle, right? But what is X2? X2 always take reference from the 0. So this point to this point here. So what is the distance? The distance is 9 cm, right? So we must put times 9. Okay. Now by doing mathematics here, we will get XR is equals to this number is 216. Take a calculator and count. This value is 81. Okay, this part we need to divide, bring over. divide. Okay, this answer will be 27. So this one is equivalent to 5 centimeter. Okay, what is the meaning of 5 centimeter? Obviously, it's with respect to the 0 here, 5 centimeter. So it's around here. Okay, so from here to here is 5 centimeter. Okay, but the question, see again the question what they asked. Where will be the center of gravity be at G, where OG is? Okay, this center of gravity is G. OG. Now this is what they're asking. OG is what? The radius is 6 cm. This is 5 cm. Obviously, OG is 1 cm. That's why the answer is C.